Okay, so this is a self-created problem, which is nitrogen gas is kept at 80 degrees Celsius and a pressure of 200 bar. Data for nitrogen are molecular weight 28 gram per mole, critical temperature 126.2 Kelvin, critical pressure is 34 bar, and omega is 0.225. Can ideal gas law be used to calculate the specific molar volume in this system? Explain your answer. So basically this is what we need to do, and we need to check either ideal gas law is valid or not. But before that, we can use this criteria about ideal gas law validity or selection criteria, and the starting point is specific molar volume, which is volume over number of moles. So using PV is equal to nRT, so this is the starting point for this thing. So first of all, we will calculate specific molar volume, and that is equal to RT over P, which is R is a universal gas constant, temperature is T is temperature, and P is pressure. So if we are dealing with diatomic gases like nitrogen, hydrogen, and carbon monoxide, for diatomic gases we calculate this specific molar volume, and if the answer is greater than 5 liter per mole or 80 cubic feet per pound mole, if answer is yes, that means ideal gas law is valid in that case. If answer is no, mean the specific molar volume is less than 5 liter per mole, in that case ideal gas law is not valid, and in that case we have to use real gas equation of states like van der Waals equation. What is the reason for that? Because if the specific molar volume for diatomic gas is greater than 2 liter per mole, greater than 5 liter per mole, in that case, if we use ideal gas law or the real gas laws, the difference would be less than 1%, or relative error between both equations would be less than 1%, which is negligible. But if for diatomic gases the specific molar volume is less than 5 liter per mole, in that case the difference between ideal gas law and real gas equation of state would be much bigger than, relative error would be much bigger than 1%. So that's why this is the logic behind this. On the other hand, if we have other gases like carbon dioxide, NO2, etc., if we have other gases, the criteria is a little bit different. For other gases, the specific molar volume should be greater than 20 liter per mole, and if answer is yes, the ideal gas law is valid, and if answer is no, in that case we have to use the real gas equation of state. Again, the logic is the same. So if the specific molar volume for other gases is greater than 20 liter per mole, either you use real gas or use ideal gas, the difference in answer would be less than 1%, which is negligible. So this is the criteria behind, or checking the validity of ideal gas, and this is how we decide either in a given circumstances ideal gas law is valid or not. Now using this knowledge, we can solve this question. The first thing is Nitrogen. Nitrogen is a diatomic gas, right? So we can write this based on the data. So here we got the data. So first of all, nitrogen is a diatomic gas. Then we have temperature. Temperature is 80 degrees Celsius. So temperature is 80 degrees Celsius. We can convert this into Kelvin by adding 273, right? And as a result, we get 353 Kelvin. And pressure is 200 bar. The other information about nitrogen, like critical temperature, critical pressure, omega, which is a damping factor, it's not relevant, so we will not use this. So basically, we need to check the validity of ideal gas. And for that, we need to use ideal gas law, which is PV is equal to nRT. And if we rearrange this equation, V over N is equal to RT. So this volume over number of moles, this is called specific molar volume, right? This is what we are looking for. And this is denoted by small v, right? So we can do this here, like pressure specific molar volume is equal to RT, right? Because we need to calculate specific molar volume, that is equal to RT over P. So that means we need information for R, which is universal gas constant. So we need an R value which has units similar to temperature, which is Kelvin, and pressure bar, and specific molar volume as liter per mole, because we need to check the criteria. And for that, universal gas constant value which is suitable is 0.0831 liter bar over mole Kelvin, right? So this is the suitable R value which we can use. So now, using these informations and this data, we can just use this equation, which is for specific molar volume. R is 0.0831 liter bar over mole Kelvin. Temperature is 353 Kelvin, and pressure is 200 bar. Now this is, I have put all the values, so I can cancel few of them. Bar can be cancelled with bar, and Kelvin can be cancelled with Kelvin. So now we can get specific molar volume as 31 multiplied by 353 divided by 200. So specific molar volume answer we get is 0.15 liter over mole. And as you guys know that for diatomic gas, which is nitrogen, if specific molar volume is greater than 5 liter per mole, basically in that case ideal gas law is valid. And if specific molar volume is less than 5 liter per mole, in that case we have to use real gas equation of state. So you can see that in this case this is less than 5 liter per mole, so basically we have to use real gas equation of state, and ideal gas law is not valid. So basically this is the simple question which check the validity of the ideal gas. I hope this thing is clear to you guys, and I hope this is simple and straightforward, right?